Welcome to the fourth and final session in this module on climate literacy for primary care staff. In this session, we will be examining which sectors generate greenhouse gases. We will look at how much they emit and how they've responded over the last decade or so. We will consider where the biggest challenges still lie as we work towards a net zero carbon economy and society. A quick recap from the last session. We had a look at some of the vulnerabilities faced by different countries around the world and saw that the impact will not be evenly spread. We have seen some of the likely impacts in the United Kingdom around flood risk, wildfires and air pollution. We have seen the results of the international discussions at the IPCC and United Nations and how they've been translated into legislation in the United Kingdom in the Climate Change Act. Previously, we touched on the difference between direct carbon footprints and consumption-based carbon footprints. We can use this knowledge to help understand the approach by two different government departments and see why it's important. The report from the Department for Business, Energy and Industrial Strategy reports emissions on a territorial basis, so they include emissions only which occur within the United Kingdom borders. This means they exclude any emissions from UK businesses and residents that occur abroad, including any from international aviation and shipping, and any emissions embedded within the supply chain of manufactured goods imported into the United Kingdom. Therefore, they use the lower figure, which is reduced by moving manufacturing overseas. This shows a fall in UK direct emissions, but will not see a reduction in overall global carbon emissions. DEFRA, on the other hand, use figures based on consumption and use estimates for each stage of the supply chain, including that from overseas manufacturing. Why is it important to distinguish between the two? Well, according to the Department of Business, Energy and Industrial Strategy, in 2018 the total carbon equivalent emissions was just over 450 million tonnes. This is a fall of 43% from the 1990 figure. However, if we use DEFRA's methodology, the total is 772 million tonnes and represents a fall of only 9% since 1997. We saw in the first session that not all greenhouse gases are the same when it comes to the impact on the climate crisis, with fluorinated gases being much more potent than carbon dioxide. This chart was produced by DEFRA and shows the difference between the two figures for consumption emissions and direct emissions for the United Kingdom since 1997. The carbon dioxide footprint, on a consumption basis, is notably biggest due to the impact of embedded emissions in imported goods. The inventory also measures emissions on a territorial basis, which only include emissions which occur within the United Kingdom borders. This chart shows the greenhouse gases produced by UK households, by the United Kingdom produced goods and services, and by imports. Greenhouse gas emissions generated directly by households account for about 17% of the total. Over the last 20 years, this has remained remarkably consistent, with only a slight decline in recent years. Part of this decline has been attributable to austerity measures. The carbon dioxide emissions from UK produced goods and services has declined by 31% since 1997. There was a marked reduction after 2008 due to the impact of the global recession caused by the collapse of various members of the banking and financial sector across the world. Part of this fall is also due to the decarbonisation of the energy supply. We will break this figure down into its constituent parts shortly. Carbon being imported in goods and services has risen. For example, goods from China have increased by 260% between 1997 and 2017. Overall, the footprint from greenhouse gas emissions for the United Kingdom has fallen from its peak in 2007 by 21% to 2017. Carbon dioxide accounts for about 80% of this total. Of the 770 million tonnes of greenhouse gases emitted each year, carbon dioxide accounts for about 80% of it, followed by methane at 10% and nitrous oxide and fluorinated gases around 5% each. Most greenhouse gases are emitted through the transport and energy sectors. The next three biggest areas are business, residential and agriculture. Roughly speaking, transport accounts for about 26% of emissions, with energy a further 25%, and business and residential at 17 and 14% respectively. These proportions change each year as the total greenhouse gas emissions fall. The land use change and forestry sectors act as a net sink for carbon and therefore appear as a negative value on this graph. These are the main sectors and their emissions. These figures exclude life cycle emissions from bioenergy grown overseas, the UK share of international aviation and shipping, and the greenhouse gases generated when goods are imported into the United Kingdom. The last factor is again particularly important to note. For the past few decades have seen a dramatic rise in the exports of consumer goods from countries such as China, which has a very coal-intensive electricity generation mix and therefore higher emissions. Not all sectors emit the same greenhouse gases. We can see the transport and energy sectors mainly emit carbon dioxide. The energy sector also produces about 10% of the United Kingdom's methane emissions. This proportion may rise significantly if fracking is undertaken in large amounts. It's calculated between 2 and 6% of the gas produced from fracked wells is released into the atmosphere through venting, flaring and leaks. Businesses are the main contributor for fluorinated gases, often through the refrigeration and cold chain. Agriculture and waste management are the main producers of methane, accounting for nearly 90% of the total UK emissions, whereas nitrous oxides, around 75%, comes from agriculture. Therefore, each sector needs a sector-specific plan to reduce their contributions. We can use this data to start to delve into the details of which sector has reduced their emissions so far and which have yet to do so. The transport sector, which remember doesn't count aviation or shipping emissions, has not really fallen much in the last 30 years. However, the energy sector, shown here in green, has made very large reductions and has been the most successful sector to decarbonise. Other sectors have done well. Waste management moved from disposing of waste in landfill, where methane and other gases were released, into encouraging better recycling rates and anaerobic digesters for food waste. Electrical waste, such as fridges, have had their gases removed safely now rather than being dumped and the cooling elements released to the atmosphere. Industrial processes look like they have made big reductions, but many of these have been because of moving the supply chain overseas. The greenhouse gases are still being produced, just not within the boundaries of the United Kingdom. The improvements in the power and waste sectors can be seen here. However, we can now also see the contribution made by flights and ships. This has been a growing sector in the last 20 years as people and goods are transported around the planet. We will start by looking at the biggest emitting sector, that is transport. This covers road transport, railways, domestic aviation and shipping, and fishing. In total, it is responsible for 26% of the United Kingdom emissions. The main source for emissions is from the fuel, either petrol or diesel. Since 1990, there has been a steady increase in the total distance travelled. Between 2008 and 2012, distances and emissions fell due to the global recession and banking collapse. Of the different methods of transport, passenger cars are by far the most significant. Most of the emissions are carbon dioxide, but nitrous oxide and methane emissions are influenced by the vehicle's age and type. At the same time, there has been a small drop in the amount of greenhouse gases being generated, by about 4%. The reduction in emissions had been due to more miles travelled with diesel vehicles and improved energy efficiency of the internal combustion engines. In the last few years, the move toward diesel cars has been reversed, particularly when the link between diesel and other pollutants, especially fine particles and air pollution, has become more apparent. Therefore, with rising distances travelled and more petrol vehicles, it could be reasonably anticipated that this sector's emissions may rise. Different methods of travel emit different amounts of greenhouse gas. We can consider what transport options are available for a family of 4 if they wanted to go on holiday to France. How could they travel from London to Paris? The family could fly. According to carbonfootprint.com, travelling from London to Paris in economy class and back again would emit 440 kilos of carbon for the family. Or they could travel by a medium-sized petrol car via a ferry from Dover to Calais. This would emit 173 kilos per car. Or they could travel on the Eurostar from London St Pancras to Gare du Nord in Paris. This would emit only 10.5 kilos per passenger. For the same journey, flying is the biggest emitter per passenger. A flight from London to Paris for the family generates nearly half a tonne of carbon dioxide, whereas travelling by train is the most efficient and produces about 1/10 of the carbon dioxide, with the family producing about 40 kilos of carbon in total. For personal transport, electric vehicles are starting to make inroads into sales. In 2019 there were 80,000 electric vehicles in the UK, the biggest number to date, and it sounds quite impressive. However, the total number of vehicles sold was around 2 million, which means electric cars make up about 5% of new sales. It is likely to be some time before they make a significant contribution to the overall distances travelled. All cars generate greenhouse gases as part of their manufacture, and electric cars are no different. These are known as upfront carbon emissions. The bigger the vehicle, the bigger the upfront cost. Volkswagen have produced a life cycle assessment for a petrol Golf and an electric Golf. This is known as From Cradle to Grave and covers greenhouse gas emissions from the manufacture, use and disposal of the product. While the upfront emissions are greater for the electric Golf, the running emissions are lower. The biggest hotspot is the manufacturing process of the battery. Salvaging batteries after use to recycle the lithium will lead to a lower carbon cost of the battery. The use phase is only as clean as the electricity used to charge it. The Volkswagen analysis is based on the German electricity generation network, which is notoriously carbon intensive. Running on 100% wind or solar power would reduce the use phase emissions by about 60%. There are other options for decarbonising transport and travel, and these will be discussed as part of the action planning in the next module. We next look at the energy sector. This was traditionally the biggest emitter of greenhouse gases, but has reduced its emissions to now lie second behind transport. In the last session, we saw that the power industry had decarbonised their emissions through the increased use of renewable sources. In the United Kingdom, energy demand fluctuates by time of day or week and by season. Up-to-date figures of what sources are generating our electricity are available at GridWatch. This is updated every few minutes and is a reliable source of figures on the makeup of our energy generation network. On average, the United Kingdom uses between 30 and 40 gigawatts of energy each day, depending on the time of year. Nuclear power provides a baseline of about 6 gigawatts, wind can provide up to 10 gigawatts, solar 8 gigawatts and biomass 3 gigawatts. Natural gas turbines fill any gaps and produce the rest, anything up to 15 gigawatts. These power plants can be turned off and on relatively quickly. On any given day, the proportion of gas and renewable energy sources fluctuates, depending on weather conditions, time of day, to provide a seamless supply of electricity for households, business and industry. Coal produces a lot of greenhouse gas emissions in the form of carbon dioxide. Over recent years, the number of days that the United Kingdom has not needed a coal-fired power station has gradually increased. A new coal-free record has been set each year. The UK grid first ran without coal for 24 hours in 2017, and that was the first time since 1882. Since then, all but 4 of the UK's coal power plants have shut in advance of the government's ban on coal-generating electricity in 2025. Coal made up only 2% of the country's total power mix in 2019, a dramatic fall from nearly 25% just 4 years ago. The production of deep mine coal in particular has declined steadily, with the last 3 large deep mines all closing in 2015. Emissions from coal mining and handling have fallen from 21 megatons in 1990 to only half a megaton in 2018. The national electricity grid has decarbonised and become cleaner each year over the last decade. The push has been to install offshore wind farms and personal and commercial solar farms. In 2012, the average amount of carbon dioxide being released per kilowatt hour was around 500 grams. In 2020, the average has been closer to 200 grams. One day in 2019 had electricity being generated at under 100 grams per kilowatt hour, and 1 hour was even down as low as 39 grams per kilowatt hour. Another common energy source in the United Kingdom is methane. We will have a look at where this is used and how much. Methane is used by several different sectors. Around half the total methane consumption is used for low temperature heating and hot water in our homes and other sectors. These are supplied by the low pressure mains distribution network. Gas-fired power stations are also used to generate electricity. As we have just seen, this varies depending on the electricity requirements at any one time. Industry also uses methane for heating for individual processes. Most electricity and industrial consumption is from plants connected to high pressure transmission or distribution pipelines. Domestically, Most emissions are from the fuels burnt in our homes, such as for heating space, heating water and for cooking. Around 80% of domestic heat demand is supplied by natural gas or methane. Various factors influence the amount of gas used. Most significantly, naturally, is the temperature, with colder temperatures driving higher emissions. Mains domestic gas has been the mainstay for heating since its introduction in the 1960s. There was a rocketing of demand as gas central heating was installed and has become ubiquitous. Since then, the figures per customer have fluctuated between 50 and 70 gigajoules each. Changes in consumption have occurred. This is partly due to changes in heating technology, such as more efficient boilers and better heating controls, changes in behaviour, changes in the housing stock with improved insulation, changing demographics and work patterns, and the changing climate. What are the options for reducing our reliance on methane while maintaining comfortably warm homes, hot water, and being able to cook? Within the industry, policymakers are considering whether the domestic gas network could be switched off by 2050. This would involve converting hot water, space heating and cooking to a non-gas source, either electricity or hydrogen. Heating could include air or ground source heat pumps or other electrical resistance options or hydrogen burning boilers. Residential and service heating demand can be fulfilled by current technology and achieve an 80% reduction in carbon intensity as it works towards the 2050 emissions target. For example, to heat a home can be achieved by an air source heat pump. These are considered to be 380% efficient. This means that for each unit of energy used, they generate 3.8 units of heat. 1 kilowatt of electricity is turned into 3.8 kilowatts of heat out. More details of this and other practical examples will be in the next module. GridWatch also gives a breakdown of how much gas is being used by power companies. On a typical June morning, about a third of the electricity is coming from gas in combined gas cycle turbines. These turbines are maximally about 64% efficient, which means about a third of the energy going in is not being used usefully. Business is responsible for about 18% of the national footprint. Carbon dioxide is again the main emission. Overall, there has been a fall in greenhouse gas emissions of 31% since 1990. Some have been achieved through efficiencies of hardware, some through changing business practices and models. A large proportion is due to carbon dioxide from business travel and fuel consumption, energy use and F-gases from top-ups made to air conditioning, fire protection equipment and refrigeration units, but also from any goods manufactured or sold and used. In the next module, we will see which parts of general practice generate the most carbon emissions and what we can do to reduce them. Domestic emissions are responsible for 15% of the country's overall emissions. Most of these are carbon dioxide from burning methane in the home, as we've just seen. However, we also release fluorinated gases when we use aerosols with propellants and medical inhalers. For example, there are about 73 million prescriptions for inhalers each year, and about 70% have F-gases as propellants. Agriculture generates 10% of the national greenhouse gas footprint. It consists about 60% methane, 30% nitrous oxide. The majority of the methane is from cows and other grazing animals. They host microbes in their stomach that helps them break down and absorb nutrients from tough grasses. These microbes produce methane as their waste, which wafts out of both ends of the cow. Manure and slurry from cattle and other grazers produce even more methane. The National Beef Association calculates there were 9.6 million head of cattle in the UK in 2018. Worldwide, there are about 1.4 billion. This number is growing as demand for beef and dairy increases. A major source of nitrous oxide is due to synthetic fertiliser use. Where large applications of fertiliser are combined with soil conditions favourable to denitrification, large amounts of nitrous oxide can be produced and emitted to the atmosphere. Nitrogen-based fertiliser use in the UK over the last 30 years has fallen from about 140 kilos per hectare in the 1980s to about 90 kilos per hectare currently. There are various ways to change land management to reduce nitrous oxide release. These include using biological fixation to provide nitrogen rather than applying fertilisers, such as planting clover or legumes and pea plants, or reducing the amount of nitrogen fertiliser applied through better timing and well-directed applications, also improving land drainage and preventing the release of manure and slurry. Waste management predominantly generates methane. Historically, this has been from the rotting of food in landfill, although there have been some emissions of carbon dioxide from incineration plants. As landfill sites have closed and alternative methods for dealing with waste have been introduced, there has been a fall in greenhouse gas emissions by nearly 70% since 1990. Improved recycling rates have led to less incineration, while improved food waste collections in parts of the country and better treatment of liquid waste has led to an increase in gas being captured from anaerobic digestion plants and used for energy. Industrial emissions have fallen over the last 30 years and now contribute just 2%. Most are carbon dioxide from cement manufacture, but also lime, steel and iron production. These reductions have mainly been due to less iron, steel and ammonia being produced, all of which have been very energy intensive. We have looked at each of the different sectors and their emissions. We have seen some sectors have made great reductions through technological change such as renewable energy, but others, such as the transport sector, has made very little impact. The largest sectors for the greenhouse gas emissions remain transport, energy, our homes and our work. What can we do from here? While we will look at specific plans to reduce our contributions in the next module, where are we currently in our thinking about reducing these greenhouse gas emissions? We saw in the last session that the government target is to have net zero emissions by 2050. How long can we leave tackling further reductions? The longer we leave making changes, the more radical the change that is needed. If we had taken action when the Climate Change Act was passed in 2008, we could have reduced our carbon footprint by 5% each year and have achieved our target of a 50% reduction by 2030 and net zero by 2050. Unfortunately, although the energy sector took note, the national reduction fell short. To achieve the interim target of a 50% reduction by 2030, we will now need to reduce our emissions by 6.7% each and every year. However, if we wait until 2025, then the rate of reduction increases to 13% each and every year. The take-home message is that the very steep curve will only get steeper. There is a large challenge to reach the large, rapid-scale change needed and to close the gap between the predicted and the target level. What has been the response of the international, national and local government? As we saw in the last session, an international agreement was made in Paris in 2015. The next meeting of the United Nations Climate Change Conference is the 26th and due to take place in Glasgow. The UK government was the first in the world to set the national legislation with the Climate Change Act. In 2017, the UK government launched its Clean Growth Strategy. It recognised that the public sector will need to cut its emissions in half over the next 15 years. It will provide £255 million of funding for energy efficiency improvements across England, and it encourages carbon reporting and energy saving to become routine activities in the public sector. By the end of 2019, over 350 local authorities had declared a climate emergency. Friends of the Earth produced a league table of local authority performance. This ranked Wiltshire, Isle of Wight, Northumberland and Somerset at the top. Of the remaining councils, lawyers from Client Earth wrote to 100 of them, warning that they will violate their legal obligations and risk legal challenge if they do not introduce proper climate change plans. There are many challenges ahead. Central government has set an agenda of carbon reduction which is reported on by the Committee for Climate Change. Some local authorities are following their lead and implementing actions, where daily decisions around new and existing infrastructure, such as new buildings, roads and utilities, are being made at a local level. We have had a look at the different sectors and the amount of greenhouse gases they emit. Some sectors, like the energy generation sector, have markedly reduced their footprints. However, when projections of the amount of carbon emissions we will be able to emit by 2015 really show some stark reality. For example, the amount emitted by cars and personal transport has to become zero by 2035. The amount from domestic and commercial heating has to reduce from about 5 million tonnes to just 1 million tonnes. However, these reductions cannot just be exported to elsewhere in the world just so it no longer appears on our balance sheet. It is time for businesses and individuals to step up and put plans in place to reduce their footprint. The longer we wait, the harder this will become. And so, to recap from this session, we've had a look at the greenhouse gas emissions from each sector, We've understood what has happened and how the carbon emissions have reduced so far, and we've started to look at the future challenges. That is the end of the first module. In the next module, we will have a look at healthcare and focus specifically on primary care. We will examine the damage the climate crisis is having on the health of our patients. We will review the current greenhouse gas emissions and hotspots, and we will start to plan for the personal and business changes which we will need to improve the health outcomes of our patients while reducing our footprint. There will be practical guides, tips and hints on how to achieve this in the most painless way possible.